The next few problems are also weight-based problems where we have to determine yet again whether or not a dosage that we are given to administer is appropriate or not. So the general idea, as you remember from the previous video, is that we need to compare the order with what's recommended, and we need to determine based on that whether or not the order is appropriate for the patient. So let's look at the order first. In this problem, whatever it is, 50 milligrams IV piggyback every 8 hours. So this would be 50 milligrams every dose is what we would be giving. The recommended amount is to give 6 to 7 milligrams per kilogram per day divided every 8 hours. This is different. In the previous problem, we only had one recommended amount. Here we have two. So we actually need to consider and customize both the minimum amount of milligrams per kilogram per day. Of 6 is the minimum. The max is 7.5 milligrams per kilogram per day. Students tend to actually like these problems better because we're given a range. It's not just one value you're comparing it to. We want our order to fall within this particular recommended range. So here's the minimum, here's the maximum. I cannot make a conclusion now because I look here, 50 is in milligrams per dose. This is milligrams per kilogram per day, completely different unit. So I need to customize by multiplying by the patient's weight. I need to, if I can multiply by the patient's weight in kilograms, then I would know, at least get rid of that per kilogram. What is the patient's weight in kilograms? If we look up above, we have 40 pounds. So I need to convert that, 40 pounds. Remember, you can divide by 2.2. And what do we get? If we round that to the tenths place, we get approximately 18.2, and this would be kilograms. So if I multiply this minimum value here, 6 milligrams, by 18.2, what I'm finding is not the minimum amount for any patient, but I'm finding the minimum amount for this patient. So I'm going to take 6 times 18.2, and I'm going to get 109.2. And I'm going to leave it like that. 109.2. And if I just do that, I would have milligrams per day. I'm going to do the same thing down below. 18.2 kilograms, if I multiply here for the maximum, what's going to happen? So if I take 7.5 times 18.2, we're going to get approximately here, actually it's exact, 136.5. And this is again in milligrams per day. So here we're using the child's weight here to address this problem. We're specifically told to use the child's weight to calculate the minimum and maximum dosage for this patient. The minimum is 109.2 milligrams per day. The maximum is 136.5 milligrams per day. The question we ask ourselves next, is this appropriate? Explain in a complete sentence. Well, if you were to look at it right now and say, no, I don't think so, because 50 is not in between here. That would be incorrect. The reason why is because the 50 is milligrams per dose. This is the total amount of milligrams per day. So what we need to do is to take, in this problem, we need to take the 50 milligrams per dose and make sure that it is comparable to the recommended amount, that it is milligrams per day. So I'm going to take this milligrams per dose and figure out, well, if I follow through with this order, how many milligrams per day would the patient be receiving? That information has to be given to you. Here we're told every 8 hours. As we saw on the last page, this is 3 doses. If you're giving this every 8 hours, you would be giving this 3 times. So 3 doses here in one day. We just multiply that by 3, right? If we multiply by 3, we would be getting the total amount of medication per day, which would be 150 milligrams per day. Now, we could have also taken the recommended amount and divided it into 3 pieces, right? We could have taken this. If this is per day, we know we're splitting it into 3 equal pieces. We can divide this by 3 or divide this by 3 to change the range into per dose. So that would be acceptable too. The idea is that we need to get the order and the recommended to match. So if you need to make more adjustments to the recommended so that it matches the milligrams per dose, feel free to do that. But I decided to change the milligrams per dose for the order into milligrams per day. Is it appropriate? We would say no. It is not, because 150 milligrams per day is not within the recommended range for this patient. So we would say no, it is not appropriate because 150 milligrams per day, the order, if we follow through with the order, is not within the recommended range for this patient, specifically the patient weighing 40 pounds. A few more examples are in this video. Let's take a look at them now. Here we have two more examples where we need to determine whether or not the order is appropriate for a patient. So if you want to pause this video and give both of these a shot, please do, but I'm going to go ahead and work through them. So for the first one, a doctor orders 200 milligrams of Rocephin to be taken by a 7-kilogram infant every 8 hours. That's the order. That might be a good place to start. This is 200 milligrams, and this is per dose. The medication label shows that 75 to 150 milligrams per kilogram per day is appropriate for an infant in this case. Is the doctor's order within the range? Show all of your work. So remember, in order to determine whether or not it's an appropriate order or not, we need to take what's recommended and compare what the recommended is to what the order is. And in this problem, the recommended is in 75 for the minimum, if I were to consider the minimum, and the maximum. The recommended is 75 milligrams per kilogram per day, and the appropriate maximum dosage is 150 milligrams per kilogram per day. And this is for any infant, this is for any child in this case, because it says per kilogram. But we need to customize the recommended amount. You're going to hear me say that multiple times. Customize the recommended for this patient. And this patient weighs 7 kilograms. So I'm going to take each of these and multiply by 7 kilograms over 1. And if I do that, then I will be adjusting this range not for any patient, but for this patient in particular. So when I multiply 75 by 7, I get 525, and this again would be milligrams per day. Milligrams per day. And if I multiply 150 by 7, this will be 1,050, and this will be milligrams per day. So we have now a recommended range that is customized for a patient weighing 7 kilograms. 525 milligrams up to 1,050 milligrams every day. The problem is the order. I need to compare the order to this. Is it within the range? Incorrect interpretations are no, because 200 is less than the minimum. This isn't appropriate. However, that would be incorrect. The reason why? This is in milligrams per dose. This is in milligrams per day. So what I need to do is to consider how many times would I be administering this order. According to the order, I need to give this every 8 hours. So every 8 hours means that there are 3 doses. So I need to change this 200 milligrams every 1 dose. If I multiply by 3, because there are 3 doses in 1 day, then I will be converting the number of doses into this number of days here. So I would be giving, in this case, 600 milligrams per day. So if I follow through with the order, I would be administering this patient 600 milligrams per day. Now that the labels match milligrams per day, I can say, yes, this is within the recommended range. So I would say, yes, this would be appropriate because the order is within the recommended range for a 7-kilogram patient. For the next one, we have an infant weighing 14 pounds 9 ounces, and she is to receive Principin 130 milligrams every 6 hours. Now here we're given a little bit more information. That is, adults and children weighing over 20 kilograms are given one particular dose, 250 to 500 milligrams, 4 times a day in equally spaced doses. And the children weighing 20 kilograms or less need to be given 100 milligrams per kilogram per day in equally spaced doses, and that's 4 times a day. So a lot of information here. If you are trying to just take numbers and convert them and move things around, it's going to be challenging. So a good thing to consider is remembering here that we need to compare the order with what's recommended. That's the big picture. The problem is, if we were to write down what the order is 130 milligrams, and that's per dose. We would be giving that every 6 hours. If we look at the recommended, well, first of all, we need to calculate the patient's weight in kilograms in order to determine which one. Then we'll put that here. So what is the patient's weight in kilograms? This is a nice little review here. 14 pounds, 9 ounces. This is not 14.9 pounds. We need to first take this ounces and convert it into pounds. This ounces is a fraction of a pound. What fraction? Well, we know 1 pound is 16 ounces. So what we get here, if we divide 9 by 16, what we get is 0.5625. So 0.5625. I'm not going to round this. That's how many pounds are equivalent to 9 ounces. So we know the patient weighs a total of 14.5625 pounds. That's how many total pounds the patient weighs. And now I'm going to divide that by 2.2 to get kilograms. So if you divide that by, so 14.5625 divided by 2.2, we're going to get, now this is going to, we'll round this to the thousandths place, 6.619 kilograms. A lot of stuff going on, and we haven't even really gotten to the heart of the calculations here. We need to convert ounces into pounds. We know the patient weighs a total 14.5625 pounds, dividing that by 2.2. Because we have a patient weighing less than 10 kilograms, we have to round this to the thousandths place. So go out 3 decimal places, 6.619 kilograms. Now that we have that, we can choose here that we need to follow this recommended amount, weighing less than 20 kilograms. The patient needs to receive 100 milligrams for every kilogram per day. So what I'm going to do is to multiply by the patient's weight. We need to customize this for this patient. Customize it for this patient. What do we get? So 6.619 times 100, you're going to get 661.9, and the unit would be milligrams per day. This is what's recommended for this patient. However, the order would be 130 milligrams per dose every 6 hours. So we know that this is 4 times a day. So 4 doses. So 130 milligrams per day. You know the big picture here, I'm trying to convert milligrams per dose into milligrams per day. And the reason why is I need to compare that to the recommended. So if I multiply by 4 doses, I'm going to get 520 milligrams per day. So we see here that we have 520 milligrams per day. That's what the order, if we follow through with the order, that's how much we would be administering. The recommended for a patient weighing 6.619 kilograms is approximately 661.9 milligrams, or about 662 milligrams. Is this safe? Now this can be a little tricky. This is well below the recommended amount. So it might be safe, but because it's so low, we might want to check with the prescriber. we want to be within, a few milligrams. We want to be within a few milligrams of the recommended amount. So I would say it may well be safe. It may be safe. But we want to check with the prescriber. Why? Because it is significantly less than the recommended amount. Now you might be saying, no, can't you just give it because it's less? No, it's not going to really hurt the patient if they receive less. And we can't know that for sure. We tend to think about taking too much medication as being not safe, but sometimes taking not enough is equally as inappropriate. We want to make sure that if we're given a recommended amount given to us by that label, this could very well be a mistake by whoever prescribed this medication. We want to check. Especially antibiotics. Taking a little bit of antibiotics below a recommended amount could be damaging, as we know. We want to take antibiotics as they're recommended. So we want to, since this is significantly less than what's recommended, we want to check with the prescriber.